Hello, welcome back to 14 Minesweeper variants. Look at that, I'm done with H8. The red is very jarring, especially on this color, but on this colored background. But it's okay, we won't really be seeing this red anymore once we go into cross. Alright, so let's do cross. Cross is also an okay variant. I think it's not that difficult. It is a bit like wall in the fact that they give you a bit more information than the number itself. But the main rule of cross is clues represent a number of mines in colored cells and non-colored cells in some order. So for example, 1, 3 means 1 mine in one of the colors and 3 mines in the other color. And the order could be in any order. So it could be 1 dark mine and 3 light mines, or 1 light mine and 3 dark mines, as you can see from these two examples here. And so yeah, that's how clues work. Let's go. Alright, so the first deduction that you can make is that the numbers given here are actually additional information, because if you sum the two numbers together, you actually get a regular Minesweeper clue. So this is actually a 2, and the reason why is because considering the box around it, you have this number of light cells plus this number of dark cells, which will give you every single cell that touches this clue. So summing them together will give you, naturally, the total number of mines in all the cells around it. So this 02, for example, well, I mean, it would just be a 2. It's not very useful here, but it is just a 2. And yeah, we're gonna be using that quite a lot in cross, because yeah, it's just a thing. Alright, anyway, let's start with this 02 over here. This 02 implies that there's 0 of one color plus 2 of the other color. Well, there can only be 2 light mines, whereas the 2 cannot refer to dark mines because there are not enough dark cells for 2 mines. So the 2 has to refer to light mines, there are 2 light mines therefore, and therefore there are 0 dark mines, as expected. Okay. Is that thing counting up? Yes, it is. Alright, this 2-2 over here implies that there's 2 mines of some sort plus 2 mines of another sort. And either way, you know, both colors have 2 mines in them, right? So light mines have 2 mines in them, therefore it already sees 2 light mines, therefore these are non-mines. We can do something similar here. This 2-2 over here, which I realize now is pretty hard to see when the entire thing is highlighted yellow, implies that there's 2 light mines, and therefore this has to be a mine. Okay. Well, we can start using the 0-1 now, because if you think about, you don't have to think about these as regular Minesweeper clues, but you can if you want to. If you think about this as a 4 and a 1, you could see that in this area over here, there is at least 1 mine due to the 4, and that will complete the 1. So that means that there is a mine here and no mines here. You could also think about it with the fact that there are 2 mines in the dark cells here and 1 mine total in this entire region, and therefore because there's at least 1 mine here as a result of the 2 mines due to like min-maxing, there will be no mines here. So no mines here, mine over there. Okay. And so yeah, now we're going to use regular Minesweeper. This is just a 1, this is just a 1, and this is a regular Minesweeper pattern, so those are both non-mines. Yeah, okay. Now we actually know that there is exactly 1 mine here, and the reason why is because of the 2 here seeing already 1 dark cell. It must see another dark cell. However, it only sees 1 dark cell and not 2. Therefore, the numbers here in this clue, the 2 cannot refer to dark cells. The 1 is referred to dark cells, because there aren't enough space for 2 dark mines. And therefore the 2 refers to light cells, implying that there's a mine right here. Okay, 0-1. Well, 0-1 is just complete. There's already 1 mine here, so none of those are mines. 0-2 is very similar to this one that we did before. And finally, the remaining mine count. Well, we already know from our previous marking that there's exactly 1 mine in these 2 cells. Because we are lacking 1 mine out of the total number of cells remaining, that discrepancy of 1 mine will come in here, which means everything else is a mine. Now this 0-1 is complete, so that's empty, and therefore mine goes there. Ta-da! So yeah, that's exactly, well, it's not exactly, but that's just how cross is. It's not really that challenging. Yeah, cross is not challenging. Cross is like, I think definitely the easiest. Let me see. Actually, D is not that tough either. D is not that tough. X is not that tough. I think M is okay as well. M is somewhat okay. Yeah, so in the list of the right side variants, yeah, it's not the toughest one, definitely. Alright, let's keep going. 0-2 is trivial. 1-2, well, already sees 2 mines, so here we can say that you can't have a mine here, otherwise there will be 3 dark mines, and like this number doesn't even include 3 in it, so that's not a mine. There is therefore 1 mine in here. Now this 2-2 here implies 2 dark cells, so those are both non-mines. It also implies that because there's exactly 1 light mine here, there must be another light mine over here to finish 2. 1-2 and 1-3. Well, for this 1-2 over here, the 2 must be referring to light cells, and the 1 must therefore be referring to dark cells, so that's a mine. 1-3, well, 3 must be referring to light cells because there aren't enough dark cells for it. Therefore, the 1 must refer to dark cells, and because there's already 1 mine here, that's empty. 1-1. Well, 1-1 implies 1 of each color, so that's a mine. We can also use the 3 and the 1 here. There is exactly 2 mines in here, and there is exactly 1 mine in here. So this forms a sort of pseudo 1-2 pattern where this is a mine and this is not. That is therefore not a mine, and therefore that's a mine by previous marking. 0-1 is complete. 1-1 means that's a mine. Is that a 1-2? I can't even tell. It's a 1-2. But the 2 refers to... Well, yeah, well, I mean, we're done, right? This is just a 3 clue, and there are already 3 mines around it. I'm sorry, I should really get rid of the markings. This is a 3 clue. This is a 3 clue, and there are already 3 mines around it, so it's complete. That's not a mine. 0-2 means that... Well, there's already a mine in dark, so 0 can't be referring to dark mines, therefore that's not a mine, that is. 1-3 means that... Well, the 3 must be referring to dark cells, so that's a mine and that's not. Ta-da! Okay. Next. Oh, 0-0, what a nice number. It's just 0 of everything. Okay. The 1-1-2-2 is interesting because it implies that there's exactly 1 of each color here. However, if you do some subtraction, you also realize that in this box there is 1 of each color, right? There's 2 darks outside and 1 dark inside, so there's 1 dark outside, and same for the lights. So if there's 1 of each color in here, then it's pretty trivial that that's a mine, and there's exactly 1 mine in here. 0-1 means that's empty, therefore that's a mine by previous marking. That's a mine that's not by previous marking. Okay. So this 1-2 implies what? Implies there's exactly 1 mine here to complete the 1-2 thing, because this 1-2 is actually just a 3 clue. We can now use regular Minesweeper because that's a lot simpler to think about. This 2-3 is actually a 5 clue, and if you look at it, the 1 mine in here plus this mine gives you a total of 2. Therefore, the 5 would need 3 more mines to finish the 5. We now know that the 5 now sees 3 light mines, so the 3 must be referring to light cells. Therefore, that's not a mine. Okay, and therefore for this 1, that's a mine. 0-1 means that must be a mine, therefore that isn't. 1-2 is just complete as a 3 clue. 0-4 is very polar. It really just means that these are both mines and this isn't, and there you go. New set unlocked. 6x6. Yeah, so once again, not too challenging. We'll see how it goes. But really, the X variant doesn't really have a very large scope. It's just a thing. Alright, 2-3. 2-3 is a 5 clue, so those are all just mines. 1-2. The 1 must be referring to dark cells because the 2 can't refer to dark cells is not enough. Therefore, that's a mine. And there are exactly 2 mines in here. Okay. Is it this? It might be, actually. It might be. Let's take a look at... Yeah, this is actually really interesting. I think that's always a mine. Yes. Yeah, I mean... we know in this area over here, the 2 must refer to dark cells. One of the 2s. So there are 2 dark cells out of these 3. However, this 1-1 implies that around this box, there is exactly 1 dark mine. Therefore, this can have a maximum of 1 because of this. And because there are 3 dark mines here... 2 dark mines in these 3, then there's a minimum of 1 dark mine here as well. So this is just a really interesting case of min-max where there's exactly 1 mine in one of those cells, giving you 1 mine here and no mines here. Cool. 1-1 is just regular Minesweeper pattern. 0-1 again Minesweeper pattern. And I guess, yeah, the 1-1 means there's 1 light mine, so that's a mine. Now we can use the 2 and the 2 here. There's 2 light mines here, so there's at least 1 of these being a mine. That would complete this 2 light mines, so that's not and that is. Yeah. Okay. There's exactly one light mine around this area, so that's a mine. Therefore that's empty. Okay, 2-3. 2-3 is complete, it's a 5 clue. 1-2, well, it already sees 2 light mines, so it can't see anymore. And it sees 1 dark mine as a result. 1-1 means that's a mine. We don't know about this one. This 2-2 means that's a mine. And as 1 mine remaining, we know that a mine has to go here because of this. So none of these are mines. This 1-1 clue means that's a mine that isn't. Ta-da! Okay. Alright, so yeah, we saw like rather interesting logic with this 2-2 and this 1-1 over here. I don't think I've actually seen anything that complicated up till that point, but I guess we just did. Anyway, alright. 0-2. Well, okay, well, the 2 definitely can't refer to light. And the reason why is because if it did refer to light, that immediately breaks this 1-1, where the 1-1 implies that there's only 1 light mine around it. So the 0-2 must refer to dark, right? And therefore there are 2 mines in these 3 cells. Oh, sorry. Yes, but there are also 0 light mines as a consequence. So those are just non-mines. This 0-2-0-1 is just a regular 1-2 pattern. So that's that. 1-1-1-1 is regular Minesweeper. There's 1 mine in here. 1-1 here means that's a mine. And one of these are mines. What else do we have? 1-3. Well, 3 clearly refers to dark cells. And there's only 1 here, so these are both mines. There's also 1 light mine, so that's a mine. This 1-2 is a 3 clue, which is complete. So those are both mines by previous marking. 1-2, the 2 is complete in the dark cell, so that's not a mine, that is. 1-1 is complete. 0-2, well, that's trivial. 2-4, wow, okay, 2-4. I mean, clearly the 4 is referred to light cells because there aren't enough dark cells. And the 2 on the dark end is complete, so that's not a mine. 0-2 is complete. 1-1-1-3. Well, the 1-1 already sees 1 light, so that's not a mine, that is. 3 can only refer to dark cells, so that's a mine and that isn't. 1-2 is complete. 1-2 can be completed. 0 mines remaining means those are non-mines. And there you go. We've unlocked D5. Sweet. Next. Just keep going, shall we? Like, let's do... So, yeah, the calling process in 2x, if... yeah, the calling process in 2x is really like it's not intricate, but it's pretty smart. Like, it just does that for you by calling itself. So a lot of times you can click, sometimes you can't really, but most of the times you can click. 1-2-1-3 means there's exactly 1 mine here. Can we do anything better with that? I think we have to. Okay. I suppose what's interesting is that for this 1-3, 3 cannot be referring to dark cells. The reason why is because if it did, that immediately breaks this 1-1. So 3 must refer to light cells, so those are all mines. 1-2 means that the light cells are the things that has 2. There's therefore 1 dark cell here, which will complete this 1-3, so that's not a mine. 1-2 over here already sees 1 dark and 2 light, so those are non-mines. This 1-1 means that's a mine and that isn't. 1-3, well, 3 clearly refers to light cells, so those are mines. That's empty. 1-2, well, the 2 is already complete by the light cell, so those are non-mines. 0-1 is complete, therefore that's a mine that isn't. 1-3 means those are both mines. 1 mine remaining. We know there's 1 mine here because of this clue, so none of these are mines. This 1-2 is complete, therefore mine goes there. Oh, I did more than I... Oh my goodness, I did more than I was supposed to. It's fine, I'll finish it up anyway. What? Wait, yeah, I did 4 5x5s. Alright, that's okay. Oh, I went back to 5x5, no wonder. I was like, have I not, like... Yeah, alright, that was a me problem. Anyway, yeah, let's see how Cording gets out. Let's see how far Cording gets us, actually. The Cording got us really far there. Anyway, 1-1 over here means that there can only be 1 mine in here. Therefore, the 2s must be referring to the light mines, because it can't be 3. So these are all mines for the 3, referring to the dark. The 1-1 means those are non-mines. This is not a mine either. 1-2-1-3. Well, the 1 can't be referring to light cells because there are already 2 mines in there. So the 1 must be referring to dark cells, which means those are non-mines. Also 1 mine in here. That does complete the light cells for the 1-1, so that's not a mine, and that is. 0-1 means that's empty, therefore that is. 1-2 means that's empty. That's complete. 0-1 means 1 mine here. That would complete the 1-2, which is actually a 3 clue. Therefore that's a mine. 1-2, well, the 2 is already completed by the dark cell, so that's empty. That is a mine. That is a mine. 1 mine remaining, and we know it comes from here because of the 1-2 clue, therefore those are empty. That ending is like identical to the previous puzzle. Okay. It's like actually identical. Alright. let's keep moving. Alright. There's bigger board now. Got more things to work with. This 1-3 is still trivial though. It's one of these mines. This 1-1 means those are non-mines. 0-0 is trivial. 1-1 already sees one light, so those are non-mines. Sees one of those cells. Actually, this 1-1 is easier. That's just a mine. That completes both of these. 0-3 means that there are 3 lights and 0 darks. 1-2 is complete. 0-1 means those are non-mines. 1-2 means those are all mines. 0-1 is complete. 1-1 means those are both mines. And like, if you're wondering how like you could go fast on this, it's really just to consider the sum of the numbers. Like 1-2 is just a 3. Just figure it not figure it out, but like think about 1-2 as a 3. This is a 1, this is a 3. And so you get sort of like a very interesting 1-2 pattern here because of this mine here. This is actually an effective 2 region, so that's a mine and that isn't. Yeah. No idea how else I could help. There's one mine here and one mine here. It's probably this 2-2 and this 2-3 I'm supposed to be looking at. Right? Not entirely sure. Okay. Okay, well, I do know that the 2-3, the 3 can't refer to light cells because if it did, then this 2 would see 3 light mines, which is impossible. So 3 must refer to dark cells, right? And therefore there are 2 light mines, of which there will be at least 1 here. There you go. There's 2 light mines, of which there will be at least 1 here. Therefore, that mine over here would complete this 2-2 for the light cell, so that's empty. That's a mine. That's my min-max over there. That's empty, those are both mines by 3-3. 0-1 means 1 mine here, therefore for the 2, this is a mine. That's empty. This 2-3 means that's not a mine, that is, therefore that's a mine. There are 3 mines remaining out of 4. And we know there's exactly 1 mine here, so the remaining mines, the remaining cells are all mines. Ta-da! Alright, that wasn't that bad. Let's keep going. 0-1-1-2 is actually the simple 1-3 on the edge of the board, so those are both mines and that isn't. 1-1 is complete, because it's just a 2. 1-1 over here, I don't think we know yet. 0-2 is obvious though. 0-2-2-2. 0-2 is obvious here as well. And 2-2 already sees 2 lights, so that's empty, and therefore those are both mines. That's empty. 0-2 is obvious again. 2-3 means one of those are mines. This 1-2 means those are both mines, therefore that's empty. 1-1 means that both of those are non-mines. 0-1. 0-1 means there's exactly 1 mine here, therefore that isn't a mine. 1-1 must see 1 light, so that's a mine. 3-3. Well, I must see 3 dark, so those are all mines, and there's exactly 1 mine in here. 1-2, well... Okay, well the 1 must refer to dark cells because they can't refer to light cells. Therefore, if there's already 1 mine here because of the 1-1 clue, that's not a mine. 2-3. Don't know what that does, but that does put 2 mines in these 3 cells. Does that help? Not entirely sure. I don't think it really does. I mean, it has to, right? There's 1 mine remaining to spot. Okay. Suppose 3 referred to the light cells in this clue. You'd have a mine here, here, and here. The 3 must refer to light cells in this clue, therefore those are non-mines. The 2-3 means that's a mine, therefore that's empty, therefore that's empty as well. That works. Okay. Okay, sure. What about this 3 being a dark indicator? Then there's 1 mine here, which would mean those are both non-mines. There's exactly 1 mine here to finish the 3 for the dark cells. There's exactly 1 mine there as well, that's fine. Yeah, in fact there's exactly 1 mine here, and that's really all we know. Suppose this 3 refer to light cells, what would then happen? You'd have this, you'd have that. 3 must refer to light cells, so those are both empty now. That's empty as well. I don't think we can do anything with that. That's really interesting. What am I missing? Might be this 2-3. I haven't really checked it. But I think we figured out that putting mines in the light cells is okay. Yeah. This must be a mine. That's empty. That's empty. And this just works. Okay. Okay. If there were... Sorry, if this is a mine, then one of these are mines. And one of these are mines. I don't know how that helps. Although I do guess, interestingly enough, as a result of this, this non being a mine means the 3 must see dark cells in here now. And therefore this is one of these are mines. And these are both mines as a result. Meaning that it's empty. Does that help? That's one of the options, right? What is the other option? The other option, which I'll mark in green, is to have mines here and here, leaving an empty cell here. Well, in this green scenario, the 3 refers to light cells, which means one of these are mines, and none of these are mines because there's already one light cell in the green scenario. Okay. Therefore, let me get rid of the yellow first. Therefore, what happens in green here? That's empty. Is this always empty? No, it's not always empty. No, who said that? Not always empty. There's one mine in here. I mean, it still depends on what this 2-3 is, but it could still be anything. Right? Yeah, it could still be anything. Huh. Wait a minute. There's still one mine I can figure out. I want to say that the answer is this. Wait, no it isn't. If it's this, then there's one mine in here. Wait, what? Wait, hold on. Yeah, if there's one mine here, then there's exactly one mine here. Oh, that means that there's no mines here or here. Oh. That's different. Okay, I think I made a wrong deduction then. Then one of these are mines. Okay, I definitely made a wrong deduction there. Okay, well, the deduction for this 2-3 still remains though, where these are both mines as a result, and therefore that's empty. So I think the answer is that this is always a mine. Boom. Oh my goodness. Alright, this 2-3 means that there's exactly one mine here. There's exactly one mine here. Now that does not tell me much. The fact that there's one mine in here though, what does that say? Well, if you place the mine here, the 2-3 would mean that's not a mine, and therefore this must be a mine. That would make that empty, which does work out, so that's fine. Okay. If this was a mine then this would be empty, then this would be empty, that would be a mine, and then that would be empty. Is this always empty? Are one of these always mines? If there were a mine here, this is empty, this is empty, then these are both empty, which gives you mines here and here, which means that's empty. Is that always empty? Okay, what if this was a mine? If this was a mine, then the 3 must be referring to dark cells, meaning these are all empty. I'll give you that as like a result, but that's not really important. This must be a mine for this 2-3, which now means that's empty, which now means that, well, this 2-3 means that's empty, and now this fails because neither color in 2-3 here can actually hit a 3. So yeah, by a very long-winded contradiction, this is never a mine. Okay, I guess that was the intended thing that was to find. 1-1 here should be trivial from here on out. The 3 must be referring to the 3 in here must be referring to the light cell, so that's not a mine, therefore that is. Now that's a mine, therefore one of these are mines. That's empty. Okay, 1-2 means that's not a mine, therefore that is and that is. 2-3 is complete. 2 out of 3 mines remaining. Well, there's exactly one here, so there's one mine in there, which means that. Ta-da! Alright, I don't know if that thing was what I was supposed to do. It looked like it was though, because there was no other way I could proceed, even if I wasn't in ultimate mode. So that's interesting, I guess. Okay, this 1-1. Alright. 1-1 means there's one of each color here. We also know there's exactly one more mine in these two because of the overlap between 1-2. Therefore, how would 1-3 be fulfilled? If there were only one mine here, then the 3 cannot be for light cells because you can't put all mines in here. So the 3 has to be for dark cells, and because there's only one mine in those two cells, those two are mines. One mine in here also implies that that's no longer a mine. There you go. 2-2 means that this is no longer a mine. There's one mine here, so there must be one mine here to fulfill the 2 of there. This 2-2 means these are both non-mines, and this is because there's only one here. 0-3 means 0 must be referring to dark cells. There's already mine light. 0-2 means exactly one mine in here. 1-1 means that that's a mine. Therefore, with this 2-2, that's no longer a mine. There can only be one mine in here. So for the 0-3, that must be a mine, and that isn't. Therefore, that's empty. 0-2 means, well, this clearly can't be a mine because 2 can't refer to the dark cells, therefore 0 refers to the dark cells, and therefore dark cells have 0 in them. 2-2 in here means that's a mine. Yeah. Okay, this 2 means that there's at least one mine in here, which will complete this 2. So that is in fact the case. Therefore that's a mine and that isn't. 0-2 means that by trivial, it's trivially. That's empty. 1-1-3-3 means 1 light, 1 dark. 3 light, 3 dark. Well, there's 3 lights right here, so we'll give that. That's empty. 0-2 means that 0 of the light, and therefore 1 more dark. 1-2 is complete. 0-2 would be complete. That's empty. 2-2, that's a mine by trivial. 0-1 is complete. 1-2 means that's a mine, and therefore that isn't. 3-3 means that's a mine. And 2 mines remaining means that those are both mines. Yay! Oh, 2x 5x5. Hey, look at that. Okay, I don't know if we'll look at that, but I don't think we will. We might. We legitimately might though. Alright, let's take a look at some 8x8 puzzles. Even though 7x7 seems to have stumped me for a bit already. Okay. 0-1. 0-1, 0-0, those are all just non-mines. Again, non-mines. 1-1 means that's a mine. 2-2 means these are both mines because, yeah. 1-1 means that. 1-1 means those are both non-mines. 0-1 and 1-1. Well, 0-1 is just complete, so we can just do that. 1-1 means that there's only one dark cell, so that's not a mine. 0-1... 0-1, 1-1. Okay. Well, there's one mine in one of those cells, so by the 1-3, only sees one mine here, so the 3 can't refer to the light cells, it must refer to the dark cells, so those are both mines. 1-3, because there's already one mine in here, this is not a mine. 1-3, again. Or there's exactly one mine in here, like in these 3 cells. Because it already sees 3 cells outside, so it must see only one more mine. Okay. Now how does that work? How would that help? Oh well, it's kind of obvious at this point, is it not? The 3 must refer to the dark cells because the dark cells already have 2 mines in them. So that implies that that's a mine and these are not. 2-3. Well, as you can see here, there aren't enough light cells for the 3. So 3 must refer to dark cells, the light cells have 2 mines in them, so those are both mines. 1-2 is complete. 2-2 means that's a mine. There's one mine in here because of the 2-3. That transfers to the 1-1, meaning those are both non-mines. Okay. 1-3. 1-2. Well, 1-2 already sees 2 dark mines, so that's no longer a mine. That is. 1-3 is complete, therefore that's a mine, therefore that isn't. Okay. I think we can sort of start looking at these numbers as regular numbers. So this 0-1 is just the 1 in these 2 cells. That's 1 in these 2 cells. Because of the 1-1 here, there's exactly 1 in these 2 cells, right? And therefore this 1-2, which sees 3 mines in total, must see a mine there. Okay. Oh, so this 2-3 is so obviously just completable, so it's all just mines. Okay. That's not a mine by... Oh, I clicked on it already. I didn't realize I clicked on it. I thought I didn't click it yet. Anyway, this 1-1 actually does help us because it already sees 1 light. It cannot see anymore, so it must see that. 3-3 is... Well, it's just completable. It's obvious. 2-2... Well, it must see 2 dark, so that's a mine. One of these are mines. We will complete this 0-1, so those are both non-mines. 1-2 means those are both mines, therefore that's empty. 3 out of 9 mines remaining. Yeah, we already see it here. There's 1 mine here, 1 mine in here, and 1 mine in here. Therefore, those are both non-mines. In fact, that's not a mine either. This one means that's empty, therefore that's a mine, therefore that's empty, therefore that's a mine. 1, 2 already sees 2 dark, so that can't be a mine, that will be. There you go. Alright, that was cool. Really interesting logic though. I wonder how often like the weird logic comes in where you have to sort of do contradictory logic. Alright. Oh, this 0, 0, 1 and 2 zeros look so suspicious. This is actually just a 5. And this is actually just a 1. And so if you compare the 5 and the 1, you realize that because there are only 4 cells in here, there must be at least 1 in these area. So those are all non-mines, and therefore those are all mines. Very cool. Okay, this 0, 1 and 1, 2 here do work with each other. There's at most 1 mine in here, therefore these must both be mines and this isn't. 0, 1. Well, these are mines. 0, 1. Sorry. I was blanking out on what to do. I think it might be the 0, 3. But honestly, I don't think I can figure out something like immediately. Might also be this 0, 1 here. If you supposed this was a mine, you get a lot of interesting feedback. This 1, 2 might also be useful for some reason. If you supposed, I don't know, this was a mine, doesn't do much. Actually, if you suppose this was a mine for this 0, 1, you'd get these all being empty, and this might be a problem. This must be a mine now, therefore these are all mines. Therefore these are all empty. But that could still be a mine. I want to say it's plausibly just, I don't know what it might be. It could be something up here that I just didn't realize. Like if this is a mine and these are both empty, so that's a mine. Or something to that extent. If this is a mine, then this is empty, these are both mines. But if this is a mine, oh, then this is always empty. Right. So yeah, if this was a mine, then because of the 0, 3, you'd have 3 mines in dark cells and no mines in light cells. However, if this was the other way around, then this would just be empty because of 0, 1. So it's always empty. Interesting. Very, very interesting. Okay. Now, next up. So we have a lot more to go from this clue alone, actually. We have a lot to get from this clue alone. Okay. So suppose 0, 1 saw a mine here. You get something that looks like this, and this now fails because it no longer fulfills 0, 3. So this can't be a mine. I mean, it should be a lot more elegant than that, though. For example, this 1, 2 can really only see 2 mines here, or a mine here. Not 2 mines, mine from here, or mine here. I don't get, nothing really shows up here either. Okay. Now what if this were a mine? Sorry, I'm like sort of like blanking out on this as well. Is it like obvious? I don't think it's obvious. It doesn't look obvious to me. If this happened, right? If it so happened to be 3 darks and no lights, this 1 2. Well, there's only one mine in here, so that must be a mine as well. I don't know what else we could derive from this. If it happened to be 3 dark, no, sorry, 3 light, 4 dark. Sorry. Okay, then 1 2 would be, well, the 2 would be fulfilled by orange. Therefore that means that these are both non-mines. Oh, in fact, I think that fails in general actually. Yeah, because that's not mine. That's non-mine by 0 1 as well, which then fails 0 2. So if orange is not valid, then I guess green is valid. I mean, sure, okay. That's really weird, but alright, I'll take it. Okay. So there's exactly 1 mine in here, and exactly 1 mine in there. I don't know how I ever got to that conclusion, but I guess I did. Okay, 1 2 here is, the 2 is complete, so oh my goodness, do not misclick. So those are both non-mines. There you go. Okay, 2 2 means that's not a mine. Those are both mines. 1 2 is complete. 2 3 can be completed. 0 2. I already sees 1 light mine, so we must see another one. 1 1 means those are both non-mines. Therefore, that isn't. Yep. This 2 2. I almost said something really. So I almost said this can't be a mine by horizontal, but we're not even playing that right now. Anyway, 1 1 already sees 1 dark, so we must see 1 light. This 1 2 is complete. Sorry. Okay, it must be this 2 2. Yeah, those are both non-mines. Therefore, that is. There's exactly 1 mine in here, so that's empty. 1 2 means that's empty. Therefore, that's a mine. Those are both non-mines. 0 4 means that. And 4 mines remaining, so those are all just mines. Wait, 4? Oh, there's 1 here, yes. Yay! That was Minesweeper. This 8x8 actually takes me a lot longer than I expect it to take, which is really interesting. But I guess that means I just gotta play more than. Well, I think at this point, I am going to head off now. The music is actually like music. What? The puzzles are actually really good though. The puzzles are really fun. So yeah, I'm gonna try and finish up the X, and then we'll move on to C, and then D. So until then, hope you enjoyed this video. I'll see you guys next time. Bye bye.